Hey everybody, welcome to Geometry, Section 8.3, Part 2, still more trigonometry. By the end of this lesson, you should be able to use trigonometric ratios to find missing angles. Last section, Part 1, was all about finding missing lengths. This time we're going to talk about finding missing angles. So, if we take a look at an example like this, here we have two sides and an angle in a right triangle, instead of having a side and an angle and trying to find a missing side. So we're still going to approach this the same way we did in the previous lesson. We're going to ask ourselves two questions. First off, what two sides am I working with? So if I take a look here, see this 18 is right next to the angle, so that's the adjacent. And the 20 is directly across from the right angle, so that's the hypotenuse. So then the second question, which function am I going to use? So which of those functions deals with adjacent and hypotenuse? Hopefully after the last lesson you've had some practice, you can recognize a little bit quicker. It's going to be A and H, cosine. So we're going to use the cosine function in order to work this. So as you know, cosine is the adjacent over the hypotenuse. So let's take all the variables and plug in the actual numbers that we use. So cosine of theta is my angle, which in this case is going to be y. And then 18 is the adjacent, 20 is the hypotenuse. So there's my equation. Cosine of y equals 18 over 20. So after we plug everything in, our next step is to get the variable by itself. Well, how can I get y all by itself when I've got that cosine right there? Well, some people might say, oh, you divide by cosine. Well, no, it's not cosine times y. It's cosine of y. They're like connected. I got to find some way to disconnect them. So if you take a look at your calculator, you'll see your sine, cosine, and tangent buttons. But if you look directly above those buttons, you should see something like this. Sine -1, cosine -1. What those are, that's the inverse sine and the inverse cosine. And if this picture were bigger, you'd see the inverse tangent. And the whole reason those things exist is to undo sine, or undo cosine, or undo tangent. So if we go back to this example here, I need to undo cosine on the left side of the equation. So what I'm going to do is I'm going to apply the inverse cosine to both sides of the equation. So here you can see in purple, the inverse cosine to both sides. Now what happens is the inverse cosine exists solely to undo cosine. So those two things will end up canceling each other out. So now I have the equation y equals the inverse cosine of 18 over 20. So you grab that calculator, our variable's all by itself now, and all you got to do is plug that in. So in order to do that, I have to hit second, and then my cosine button, and your screen should pop up and it should have the cosine -1 there. And then type in 18 divided by 20, and then press the button. Again, make sure that your calculator is in degrees. You don't want it in radians or gradients. Okay, make sure it says DEG or a little box with a capital D in there. And so you type that in your calculator and you get 25.8419. Well, I don't like to round angles to anything except whole numbers. So I'm going to go ahead and round that to 26 degrees. So that's the whole process. The idea I want you to know is to undo a sine, a cosine, or a tangent. Use the inverse sine, inverse cosine, or inverse tangent. So let's take a look at a few more examples and work those out. All right, let's take a look at question number 1. So in this example, my theta, my unknown angle, is angle A, and I want to figure out what that is. So the 13 is the hypotenuse, the 12 is the adjacent, so adjacent and hypotenuse, cosine. So cosine of theta equals 12 over 13. Now, if I need to undo that cosine, I'm going to do the inverse cosine to both sides. And again, the whole reason that that inverse cosine exists is to cancel out cosine. So now I have theta, my variable, equals the inverse cosine of 12 over 13. Plug that in our calculator. So second cosine, 12 divided by 13, and I get 22.6. So round to the nearest whole degree, that's going to be 23 degrees. Okay, problem done. Okay, let's go ahead and take a look at question number 2. So question number 2, let's pick a different color. So theta is angle A. So opposite of that is 4. Adjacent to that is the 13. So we're dealing with opposite and adjacent. O and A, TOA. So we're going to be dealing with tangent. So the tangent of theta equals opposite over adjacent. So 4 over 13. Now to undo that tangent, I have to use the inverse tangent. So I will do the inverse tangent. To both sides. Okay, so I took all that time just to write that out and illustrate what I'm doing. Pretty soon you're going to get to the point where you don't need to write all that out, and I'll show you that in the next problem. But inverse tangent cancels out tangent, and now I have theta equals the inverse tangent of 4 over 13. Plug that in our handy dandy calculator. So second tangent, 4 divided by 13, and I get 17.1, so 17 degrees. Now just a little fun fact, what if they asked us to find angle B as well? Well, some people would take a look at that and say, okay, well, angle B, 13 is the opposite, and 4 is the adjacent, so you're still using tangent, and you got to do that all over again. You think there might be an easier way? Once I know that angle A is 17 degrees, isn't it a lot easier just to say that all 3 angles add up to 180? So angle B is going to have to be, let's see, 90 minus 17 is 73. That went a lot easier. Let's do one more example. Let's do question number 5. Looks like another tangent one. In relationship to angle B, 7.7 is the opposite, 14 is the adjacent, so we're dealing with tangent again. So tangent of theta equals opposite over adjacent. Now I'm going to skip the illustration step in this case, and I'm just going to move that tangent over to the other side. And if this makes sense to you, then feel free to do that. In order to get tangent to the other side, I have to do the inverse. So theta equals the inverse tangent of 7.7 over 14. So second tangent, 7.7 divided by 14. And I get 28.8. So rounded to the nearest whole degree would be 29 degrees. All right. So keep in mind, the only time that you use the inverse of any functions is if you're trying to find an angle. If you're trying to find a length, do not use your second button and your sine or cosine button. All right, it's only when we find angles that we use that. So the more you practice this, the better you're going to get. So keep practicing, and practice with the intent of understanding, not just getting the assignment done. All right, if you guys have any questions, please let me know. I'll be glad to help you in any way that I can, and I'll see you real soon. Have a good one.